on the sum and differences of angles. In other words, the sum of A plus B, the difference of A minus B, tangent of A plus B, tangent of A minus B, and so on and so forth. So let's look at the 6 rules that we need to know. And we have sine of A plus B, the sine of some angle plus a different angle, is sine cosine, sine cosine. That's the way I think you should memorize it, not the way the textbook has it. But memorize sine is sine cosine, sine cosine. Sine is sine cosine, sine cosine. So you write down sine cosine, sine cosine. You just switch the angles. If it's plus, then it's plus. It's the same sign. Sine of A minus B is sine cosine, sine cosine. If it's a minus, it's a minus. So the rule for sine of A plus B or A minus B is sine cosine, sine cosine, and then the same plus or minus sign. If you have plus here, you get plus over here. If you have minus here, you get a minus there. So the sine of A plus B or A minus B is sine cosine, sine cosine. Now look at the cosine rule. The cosine rule is cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And just switch the angles. Okay. Well, don't have to worry about switching the angles, but you do switch the signs. The cosine rule is opposite. If it's a plus over here, it's a minus. If it's a minus over here, it's a plus. So the cosine is cosine, cosine, sine, sine. Opposite signs. Opposite signs. And then the tangent of A plus B and A minus B is A tangent plus tangent over 1 minus tangent times tangent. Tangent, add or subtract tangent, 1 minus tangent times tangent. Now what happens is if this changes to a minus, then this changes to a minus, and this changes to a plus. So in other words, whatever this sign is, same on top, opposite on the bottom. Whatever this sign is, same on top, opposite what's on the bottom. Now there are the 6 tricks. I only have written 5, but I really have 6 here. And that is, we can really come back and do this. The sign is plus minus, okay? The sign is sine cosine, sine cosine. Whatever's here goes here. Whatever's here goes here. Cosine, whatever's here, opposite sine. Whatever's here, opposite sine. Cosine is cosine, cosine, sine, sine. Tangent, whatever's here goes here, opposite sine. Whatever's here goes here, opposite sine. Now there's your 6, what are called identities for the sum and difference of 2 angles. And it can be used for 3 angles. What you do is, if you had to deal with the cosine of A plus B minus C, then what you can do is group these in parentheses, work that one. In other words, do the cosine of A plus B times the cosine of C plus sine of A plus B, sine of C, and then expand that one more time. All right, now let's look at the examples in the book. Examples like they're in the book. Now, you need to understand that the purpose of these examples is for the purpose of practice for knowing your sum and difference formulas. You don't run across, there's no need in dealing with this nowadays. This is an old-fashioned problem that's still in trick books because we have calculators and everything else. But before the calculator, you could take a lot of angles that you had to deal with and split them up into our special 30, 45, 60s and end up getting a number that you could work with, whereas you couldn't without the tables or calculators and that type of thing. So all the purpose of these are for is for practice of knowing your formulas. The formulas are very important in calculus and some other math classes. So understand what this is practice. All right, so the sine of 75 degrees could be found without a calculator by knowing the sine of 45 and cosine and 30 and 45 degrees. So here we go. 75 will break into 45 plus 30. So therefore sine is sine of the first angle, cosine of the second angle, same sine, sine of the second angle, cosine of the first angle. All right, now look what happens. The sine of 45, that's where we'll do our 1 square root of 2. Sine is a side opposite over the hypotenuse, so that's 1 over the square root of 2. Cosine of 30, that's where we draw our 1, 2, square root of 3. Cosine of 30 is the square root of 3 over the hypotenuse, side adjacent with hypotenuse. Okay, sine of 30, go back over to 30. Sine is side opposite over hypotenuse, so that's 1/2. Cosine of 40, we'll go back over to 45. 1 and 1 square root. Cosine is side adjacent. It's 1 over the square root of 2. All right, now here is a time when you used 1 over the square root of 2 is the same thing as square root of 2 over 2. Again, you get that by multiplying the top and bottom of the square root of 2. If I multiply the top and bottom of the square root of 2, it's a rationalized denominator. So look what we have here. Here we have square root of 2 times the square root of 3, multiplied together, square root of 6 over 4. So this becomes the square root of 6 over 4. Then this is 1 times square root of 2, which is the square root of 2 over 4. So this becomes the square root of 2 over 4. We now have a common denominator, so our answer, written in radical form, is the square root of 6 plus the square root of 2 over 4. Again, all this is algebra just for practice of knowing your algebra. Now, without the calculator, if you know the square root of 6 to be, what, 2.449 plus 1.414, add those together, divide by 4, and you could come up with a decimal answer. All right, let's do another problem in the notes just for the purpose of learning the formulas. We could get 175 by also doing 120 degrees minus 45 degrees. Okay, sine of 120 degrees minus 45 is 75. So this is sine. So this is sine of 120 cosine of 45 minus sine of the second angle cosine of the first angle. Now, sine of 120. Whoops, 120 is out here. How far from the x-axis? 60 degrees. So we're looking for 60 degrees then. All right. So 1, 2, square root of 3. Sine of 60 degrees is the side opposite over hypotenuse. So that's the square root of 3 over 2. Cosine of 45. 1, 1, square root of 2. Cosine is side adjacent over the hypotenuse. And now, right now, let's just learn. This is the time when I can kind of look ahead and say, well, what I need to do is know that in that method. All right, then minus sine of 45 is side opposite over square root of 2, so that's the square root of 2 over 2. And the cosine of 120 degrees. Cosine of 120 degrees, now remembering 120 degrees is in quadrant 2, that's a negative 1/2. Okay. So what we get is the square root of 6 over 4 plus the square root of 2 over 4. And that's the same answer, which it better be. All right, now again, for practice, let's do now the tangent of 45 degrees. Oh, I'm sorry, 75 degrees. The tangent of 75 degrees then would be, we're looking for tangent. This is example 3. Looking for tangent of 75, which would be what? 45 plus 30. And it doesn't make a difference whether you do 30 plus 45. Makes no difference here. All right, so this then would be the tangent of 45 degrees plus, same sign, tangent of 30 degrees divided by 1 minus the tangent of 45 degrees, tangent of 30 degrees. All right, well, let's draw our two triangles, 1, 2, square root of 3, and 1, 1, square root of 2. And let's fill these in. The tangent of 45 is side opposite over side adjacent. So therefore the tangent of 45 will be 1. The tangent of 30 degrees is 1 over the square root of 3. So this would be 1 over the square root of 3. Well, and that means down here, tangent of 45 would be 1. And the tangent of 30 degrees would be 1 over the square root of 3. All right, now let's finish it out with the algebra. What is the common denominator? Common denominator, square root of 3. So I'll multiply everything by the square root of 3. Square root of 3, square root of 3, square root of 3, square root of 3. Well, that's the square root of 3 plus 1. And this is square root of 3 minus 1. Square root of 3's drop out. All right, and again, if you needed a decimal value, you could do 1.732 plus 1, 1.732 minus 1, and get an answer. So these are some just simple little examples of learning the rules. So now let's look at a little better or more useful application of these. And this is when you go the opposite direction, when you simplify. Okay. How do we simplify? Well, we're going backwards on this type of thing. We have sine, cosine, sine, cosine. Same, the same type of angles. In other words, sine of 170, cosine of 170. Cosine of 100, sine of 100. Have the same connection of the angles. So when we have sine, cosine, then that's sine of the angles. And whatever sine rule is, if this is plus, then this is a plus. So what we get then is a sine of 270 degrees. Well, wait a minute. Sine of 270 degrees is down here at 0 minus 1. Okay. Sine is y over r, so therefore the final answer is minus 1. So with all that can simplify to a minus 1 without a calculator and that type of thing. All right, example 5 is now how do you deal with this with letters and unknowns and that type of thing when you don't have numbers, you can't use calculator. Well, we still look at this. We have sine, cosine, cosine. Same connection angles. It's the sine of 3 theta, cosine of 3 theta over 5. Sine of 2, cosine 2. So it checks. So now what is it? It's sine, cosine, sine, cosine. Sine, cosine is sine. All right, and then the two angles are 2 theta over 5 and 3 theta over 5. Sine rule is whatever this is, this is. And therefore what we get then is the sine of theta. 2 theta plus 3 theta is 5 theta over 5. 5's drop out, and so all this problem simplified. The purpose of this, again, is to learn that a lot of times in another class, like a calculus class, you would have some complicated business like this to have to deal with, integrate, derivative, whatever. And so you can simplify it to a single term or a number, and it becomes a lot easier. All right, let's look now at two other examples. Okay, this is dealing with cosine. Cosine, cosine. All right, so we have cosine, cosine minus sine, sine. Oops. Cosine, cosine minus sine, sine is cosine of the two angles. Now, whoa. In cosine, it's the opposite rule. Whatever this is, the sine is opposite. So our final answer then reduces to the cosine of 7 theta. So cosine, cosine minus sine, sine, or plus, whatever this is, cosine, cosine, sine, sine goes to cosine. Opposite signs. All right, look at example 7 here. We have sine, sine minus, whoops, this is not what the rule is. The rule was cosine, cosine, and then plus or minus sine, sine. We must get it to be exactly what the rule says. So what we do is factor a minus 1 out of this. So factoring a minus out of that, it makes the cosine positive, and it changes the sign of this, makes it minus. And so we have it to the rule that we need. What I'm trying to make a big deal out of is you don't use these 6 identities, these 6 rules on sum and difference of angles, unless they're just like the form says. They must be sine, cosine, cosine for the sine. They must be cosine, cosine, sine, sine for the cosine rule. And they must be tangent, tangent over 1 tangent times tangent. If they're not that way, then you do algebra first. Then you go work it. All right, so what we have then is minus cosine of 140 and 40. And what is the rule? Cosine, cosine rule is whatever this is, it's opposite. So therefore we get minus the cosine of 180 degrees. Now the cosine of 180 degrees, cosine of 180 degrees, cosine of 180 degrees. 180 degrees is minus 1, 0. 180 cosine is x over r, so it's a negative 1. So minus times a minus 1, the final answer is a positive 1. Okay, so again, let's look at quite a few other examples. Now, a lot of these examples I'm working are examples of the type of problems you have in your textbook. But what I want you to know is here's how you do your homework, but also here's the process and concept that you need to know about the sum and difference of angles. All right, let's look at another example here. What we have here is, again, cannot handle it too easily with a calculator, so what we want to know is the cosine of a theta or an x or something minus an angle. That's 90 degrees. Pi is 180 degrees. Divided by 2 is 90 degrees. Cosine is cosine, cosine. I'm going to go ahead and just change it to 90. Opposite sign, so it's a minus, it's a plus. Sine, sine of 90 degrees. Well, what's the cosine of 90? Here we go with 90 degrees. This is 0, 1. Cosine is x over r, so that's 0. So this is going to be the cosine of theta times 0. Sine of theta times 1. 90 degrees, sine is y over r, which is 1. So 0 times that is 0, 1 times that. So again, this simplifies to the sine. So hey, what that says then is that the cosine of any angle minus 90 degrees is just the same thing as the sine of that angle. So 120 degrees, what's the cosine of 120 minus 90, which is 30? So the cosine of 30 degrees is the sine of 120. Did you hear that? 120 degrees minus 90. So the cosine of 150 degrees is the same thing as the sine of 30 degrees, 60 degrees, right? 150 degrees, this would be, excuse me, set it backwards. This is 150 degrees, so that means the sine of 150 degrees is the same thing as the cosine of 60 degrees. All right. Okay? So let's now look at the next example. This is kind of a long one now. So what we're given is The cosine of angle A is a minus 7/25, and it's in quadrant 3. So angle A is in quadrant 3. And what's that for? Well, that's for the plus and minus. You see right here, cosine is x over r. So that means r is always positive, so 25 goes there, and x is a minus 7. And we've got to go solve for y by using x squared plus y squared is equal to r squared. So if we use x squared plus y squared is equal to r squared, we'd have 625 minus 7 is 49. So that's 576. The square root of that is 24. So y is 24, but we don't know whether it's plus or minus. The quadrant tells us that it's a minus 24 because of the quadrant. All right, same thing with b. We're given the tangent of b is a minus 12/5. Tangent is y, so that's 12 over x. But we don't know where that minus, just by looking at this, we don't know where the minus goes with 12 or the 5. Quadrant 4 says what? X is positive and y is negative, so the minus goes with the 12. And again, we use x squared plus y squared is equal to r squared, and we find r to be 13. And now we have x, y, and r's for A, for B. And now we come down and work. Sine of A plus B, sine of A minus B, tangent of A plus B. We can work them all now because we now know the x, y's, and r's for angle A and angle B. Well, sine of A plus B is sine of A, cosine, same sign, sine, cosine. And now we're going to do sine of A. Sine of A, go back to A. A sine is y over r, so it's a minus 24 over 25. Cosine of B, well here's angle B. So we do cosine. Cosine is x over r. So that's 5 over 13 plus sine of B. So B, sine of B is minus 12 over 13. And the cosine of A, that's minus 7 over 25. And notice we're going to get the same denominators. And that's going to work out to be a minus 120 over what? 325? And that's going to be 84 positive, minus times a minus, a positive 84 over 325. And then we add that, final answer is 325s for denominators, minus 36. That says that angle A plus B ends up being a minus, the sign, the minus, That means A plus B angle is somewhere where y is negative. It's either in quadrant 2 or 3, but we don't know which one yet. I'm sorry, 3 or 4, excuse me, it's in quadrant 3 or 4. Sine is negative, is y, so that's in quadrant 3 or 4. All right, well, let's come over and do the cosine of A plus B. All right, so what we have, if we'll find the cosine of A plus B and we have the sine of A plus B, then that will tell us where the angle A plus B is. It's either in quadrant 3 or quadrant 4. If this cosine comes out to be positive, then we know that we're in what? Quadrant 4. If cosine of A plus B comes out to be negative, then we're in quadrant 3 because the sine and the cosine are both negative. All right, so here we go. We're going to do cosine, cosine. Opposite sign, so it's sine, sine. And then we go look at our, we can kind of take, if you've done the numbers correctly in the A part, you can just rearrange them in here. In other words, putting them in different places. Or you can go back and calculate. Cosine of A, cosine is x over r, so that's a minus 7 over 25. Cosine of B is x over r, so that's 5 over 13. Minus sine of A is y over r, so that's minus 24 over 25. And the sine of B is minus 12 over 13. So we get a minus 35 over that 325. And here we get a minus 288, I guess. A minus 288 over 325. Minus times a minus makes that a plus. No, I'm sorry. This is a minus times a minus times a minus, so it's 3 minuses. So the answer is still a minus. So what we get is a minus 323 over 325. Now a check, one check doesn't prove everything for sure, right or wrong, but a check is the sine and cosine must be less than or equal to 1. So when you do this work, this numerator better not be bigger than the denominator. If it is, we've got a mistake somewhere in here. The cosine's negative, this part. The sine was negative, so that means x and y are both negative, so quadrant 3 is where the angle A plus B is. And we've answered the third question of the problem. Okay? So that's how we deal with that. All right, now let's go to the next question is, what is a tangent? Now, in the notes, I have the tangent of A plus B here. I want you to know that I'm not going to show that on the tape, but I'm going to show you this. The tangent of A plus B, tangent is sine over cosine. Well, remember, from the A part of this problem, the sine was a minus 36 over 325, and the cosine was a minus 323 over 325. Therefore, we can invert and multiply, and minus times a minus divides out, and our answer then, if we already know the sine of A plus B and the cosine of A plus B, then we can take those answers and just divide the sine answer by the cosine answer and get the tangent. And look, the tangent's positive, and that's true in quadrant 3. All right, now I haven't worked in the notes how you get there, but and you notice that you get the same answer. Now, if I want the tangent of A minus B, this is the D part, or really the E part, excuse me. This is the E part. I just did the D part. The E part of this, tangent of A minus, now that's a totally different situation. Totally different situation. So we can't use any of the previous work. We just have to start out and go through this one. So we want to do tangent of A minus tangent of B, same sign, one opposite sign, tangent of A, tangent of B. And so here we go. Tangent of A, well, now we hadn't worked tangent of A, so we have to go back up there in the notes and look at A. Tangent is y over x, so that's 24 over 7 minus tangent of B. Tangent of B is y over x, so that's minus 12 over 5. And then we come down here and say plus. All right, we take this same answer we got here times this answer. And now we do algebra. All right, one quick method of algebra. What's the common denominator? Common denominator is 35. So I'm going to multiply everything by 35. Everything by 35. Everything by 35. Everything by 35. Well, let's see. 35, this will divide into that, go 5. 5 times that's 120. 5 will go into this 7 times. 7 times that's 84. Now look, minus times a minus, 84. Okay. And then on the bottom it'll be 35. And then this divides out, and we're given minus 288. And so our final answer is 204 over a minus 204. That's what this adds up to, over a minus 253. Okay, so that's the process of finding the tangent of A minus B. Again, just a practice of using the formulas and going back to your X, Y, and R. Let's look at now some more examples. All right, now let's look at this example, number 10. Now, the last page of these notes is saying let's prove identities. In other words, I don't have written down over here what it equals to. You know, it's there in the notes. But what we're going to say is we're going to identity, which means I can take one side of the other one and get it to the other side. So this might be just a small part of a more complicated problem. We want to reduce that. We want to simplify that. We want to make it into a shorter version, something easier to deal with. All right, well, let's look at it. We have 5 times sine, cosine, sine, cosine. Hey, we have sine, cosine, sine, cosine. But we have the 5 in the way. So what we do first is factor 5 out. And so we get sine of 8a, theta, cosine of 2 theta, minus, and I'm going to rewrite this, sine of 2 theta, cosine of 8 theta. Just so I have the rule sine, cosine, sine, cosine. Well, look how simple that is. And that's sine of 8 theta, 2 theta. Sine rule is whatever this sine is, this sine is. And so we can simplify that to 5 times the sine of 6 theta. Again, the purpose of the problem is saying, look, we can take a complicated mess and simplify it. All right, let's go to the next example and look at dealing with this. All right, tangent 48 degrees. Again, this is just another practice problem. Well, let's see. 48 is 45 plus 3. So here we do the tangent of 45 plus the tangent of 3 degrees over 1 minus tangent of 45 times the tangent of 3 degrees. Tangent of 45, 1 over square root of 2, tangent side opposite over the side adjacent. So therefore we have 1 plus the tangent of 3 degrees is equal to 1 minus the tangent of 3 degrees. And that's the answer. Just leave it there. Okay. All right, now let's look at a very big old long problem. Not much more difficult. Just takes a lot of space to do it. Okay, so we have cosine of 300 minus theta plus sine. Well, let's see. This would then be cosine of 300 degrees, cosine of theta, plus cosine rules opposite signs, sine of 300 degrees, sine of theta, plus, now this is sine, so that would be sine of 210 degrees, cosine of theta, minus, sine rules same sign, so this would be the sine of theta, cosine of 210 degrees. Oh, okay, so we just go work this now. Let's go back over here. Cosine of 300 degrees is 60 degrees. So this is the cosine of 60 degrees. In quadrant 4, cosine quadrant 4 is positive, so we're all right. Cosine of theta plus sine of 300 degrees. Well, sine of 60. But that's in quadrant 4. Y is negative, so this will be a minus sine of 60 degrees, sine of theta. All right, over here, 210 degrees. 210 degrees is right here, 30 degrees. So this is the sine of 30 degrees. But what? Quadrant 3, sine is y, so that's negative. Cosine of theta. Minus cosine of 210. Cosine is 30, cosine of 30. So it's the cosine of 30. but that's in quadrant 3. Cosine is x, so it's a positive. And now let's see what we have. Well, let's see. Two ways of approaching this. Number one is, look, knowing previous work, the sine of 30 is the same as the cosine of 60. The sine of 30 is the same as the cosine of 60 times cosine, so these are equal. One's a minus one. That just drops out. The cosine of 30 is the sine of 60, so that's the same thing times this angle. One's plus drops out. Everything's 0. That you could do it. So you can just say from that step there, it's equal to 0. Now the other way is to go work it out. Cosine of 60, so we're going to have our 30, 60 right triangle. Cosine of 60 is side adjacent, so it's 1/2 cosine of theta. Sine of 60 is the square root of 3 over 2 sine of theta. The sine of 30 is 1/2 cosine of theta. And the cosine of 30 is the square root of 3 over 2 sine of theta. And look what happens. We have a minus 1/2 of the cosines plus 1/2. We have a minus square root of 3 sine plus, and so we get 0. So a big complicated problem just for practice of reviewing the things you need to know out of other chapters and this chapter. All right. Let's look at the last identity. Okay. What are we going to end up doing here to get this one to work? And it's a pretty straightforward problems in terms of that's two fractions. Okay, so we have fraction 1/2 minus 2/5. We multiply this times that, over this times that. Okay, so what do we get here? This times that is the cosine of theta, cosine of 8 theta. This times that is the sine of theta, sine of 8 theta, all over sine cosine. Well, look what happens. On the top, we have one of our identities. Cosine, cosine, sine, sine. So it's cosine of the angles. And if that's a minus, it's opposite sign, so it's a plus. Over the sine of theta, cosine of theta. So theta plus 8 theta is 9 theta. So the numerator becomes the cosine of 9 theta. And that's an answer. If the identity had wanted, it could have said what we want is the cosine of 9 theta times the cosecant of theta times the secant of theta. And all that's done is the identity where these move up. They're reciprocals. All right. This concludes then the chapter on dealing with sum and differences of angles.